For two lines to be parallel, they must have the same slope but different y-intercepts. We have here two equations in general form expressed as in this form. Using these two equations, and we have the shortcut for our slope. The slope can be solved as negative a over b. And for our y-intercept, represented by small letter b, is negative c over b. These two equations here, to be parallel, as we are going to determine later, must have the same slope but different y-intercepts. And we also have your Cartesian plane to illustrate it further. Let's talk about the first equation. You have your a being 1, your b is 2, and your c, your constant, is 6. So the slope of the first equation of a line is given as negative a, so negative 1 over b, which is 2. And our first y-intercept, or the y-intercept of the first equation, is negative c, which is negative 6 over 2, or given as negative 3. Since b is a y-intercept, we can also call it as a point on a y-axis, which is 0 and negative 3. Now for our second equation, our a value is 3, our b value is equal to 6, and take note for our c, it's not just 12 but it's negative 12. So our second slope is equal to negative a, that's negative 3 sixths, or in lowest terms, negative 1/2. Notice that this is the same with the first slope, so we already have the guarantee here. Next, for our y-intercept, this is actually negative of negative 12, that becomes positive 12 over 6. Our intercept here is positive 2, or given as a point on the y-axis 0 and 2. We have different y-intercepts now. This means that these two lines are parallel. To illustrate the parallelism, let us have the sketch of their graph. Let us use red for our first. We have here 0 and negative 3. We can have it here. And our rise is 1. But since our slope is negative, the run would be towards the left. This is the second point. The next point could be here, 1. And you have here, run here as well. So using the red color, this red line here is the representation of the graph for our first equation of a line. Let's see if the second is parallel to this one using color green. The point is at 0 and 2. You have here 0 and 2. The same slope, 1. But the movement for run is towards the left because it's negative. You have 1 and you have here negative as well. So the green colored line represents the second equation of a line. And you might see, even if my graph is not that accurate, that they are actually parallel to one another.